Hello everyone. In this video, I would like to present our solution RescueMate for Flipkart Gradebook Hackathon to solve Bangalore's biggest trouble. Before talking about our product RescueMate, I would like to share a small observation. During school days, there used to be a huge rush in the alley as soon as the final bell rang, whereas the same alley remained uncongested when you used to go to the assembly ground for morning prayers in queues. Disciplined schedule help in reducing the congestion in the alley. The same pattern can be observed in the Bangalore streets as well. People rush to their offices at the same time, which leads to congestion on the streets around their residential areas, tech parks, and other office premises. The congestion can be reduced by bringing discipline to the movement of the traffic. We have tried to achieve this by scheduling the traffic movement on Bangalore's streets. To schedule the traffic movement technologically, we had to predict the number of vehicles that would present on each street at a future point of time. And to predict it accurately, we need data having transit information. We can gather this transit information from different channels such as user itself provided like office reach time, movie hours, others. Bus schedules, cab and taxi bookings, hyperlocal services. Once the data is gathered, we can crunch this data to allocate a departure time to every transit plan in such a way that none of the streets crosses their carrying capacity at any instance. Now let me just demonstrate a simulation of the approach suggested. In order to show demo, we have picked target area as you can see on the map stretching from JP Nagar to Kadubesinahalli and on the other side from MG Road to Hogasandra. We have picked 6 different offices namely Flipkart Cessna, Flipkart Kormangla, Myntra, Baizu, Cars24 and Market Share marked with red flag on the map. For the demo purpose, we have increased the clock cycle by a factor of 20 which can be seen on the left hand side. We randomly selected 120 odd employees marked as blue flags. They start their journey almost at the same time without being aware of the other start time. As you can see, when they started, none of the roads were congested. Soon they reached to the main roads, creating congestion on them. Right now, you can see congestion on the Hosur road as well as Outer Ring Road. Soon the junction of these main roads, namely Silk Board as well as Agara Lake Junction itself get congested. Same congestion get propagated to the area near the destination point as you can see near the Flipkart office as well as other office place also. Now jumping to our solution. We are showing the journey of the same 120 people on the map. They had given their preferred time slot to leave home and our algorithm has recommended a start time for all the participating people. We are updating the start time as soon as they are leaving their home. Our algo ensures minimum collision on the road and reaching the destination at preferred slot range without exceeding the maximum carrying capacity of the road. This scheduling helps in minimizing the congestion from the connecting roads, main roads, junctions, as well as the nearby area to the destination points. If you are carefully watching during the same time, there was a huge congestion around Silk Board and Agara Junction. While in this scenario, when the people are leaving at the recommended time, congestion is pretty less. If you're wondering, on the need of the group in the URL, I would like to mention in order to structure different simulation, we created groups based on the number of destination points and people. For this example, we have created 6 destination points and 20 people reaching each point making total 120 people. One can change the value of the group from 1 to 6 in the link given in the PPT and explore more simulations. Now I would like to briefly explain about the algorithm. We have captured preferred time slots for each route from the users. We have made call to the Google Maps API to get route and direction information from origin to destination point. Now we iterate on a different time slot and consider those people who opt for it and try to provide a timetable schedule for them. We have used genetic algorithm to deduce the schedule. Our aim is to minimize collision over a path. For each schedule, we calculate fitness function. Greater the value of the fitness factor, better the schedule. To create variation in schedule, we have used standard genetic algorithm methodologies like mutation, crossover, and try to calculate the fitness factor of the newly created time schedule. This was a quick description of our proposed solution. Feel free to explore demo link provided in the PPT and try out more simulations. Thank you.